All right, whatever you're doing, remember, I believe that code is the single most important thing we can do if we're among the 4 or so billion people on the internet connected to the internet. The 4 or so billion people on the planet connected to the internet. For us, code is the single most impactful thing you can do to make a change, to make a difference, to change the world. There's still 3 or so billion people not yet connected to the internet, so of course we have a long ways to go. But if you're connected to the internet, code is the most powerful thing you can do. That's why I start with code. I believe code is the essence of what we're trying to do here. So note that for your own reference. I'm also on the internet. I'm happy to carry this discussion forward above and beyond our humble time together here today. So please note that Twitter handle. How many of you are on Twitter? Twitter, it's 2016. Twitter? Twitter, okay, that's a little awkward. What about email? Email. Anybody? No, okay. Well, if you're on email, you should probably consider your life choices. If you're on Twitter, great. If not, get on it. It's the new IRC. It's hot stuff, good stuff. A little bit about me. My name is Josh Long. I'm the Spring Developer Advocate on the Spring team. I'm a book author. The latest and greatest book, which is not yet finished, but we're working on it. It's called Cloud Native Java. It's sort of the long-form version of what we're about to talk about in the next 50 minutes. That bird, for those of you who are wondering, is the blue-eared kingfisher from the Javanesian island. So it's a bird, you see, that flies from Java. So bird, native bird, no? Okay, it'll come. Don't worry about it. You'll get it. It'll be fine. Also, I've done video training, so the latest and greatest of which is called Building Spring Boot Live Lessons with Spring Boot co-founder and my friend, and everybody's friend, really, Phil Webb. So there's that. I'm also an open source contributor and engineer. I am the number 1, top ranked. No kidding. Number 1, 7 years running. 7 years, more bugs per commit than any other committer. Number 1. For projects like Spring Boot, Spring Cloud, Spring Integration, Vaadin, Spring Batch, Timeleaf Activity, etc. More bugs per commit. And I work at Pivotal, and at Pivotal we care very much about open source. You can see that because I have the cute icons on my slide, but that is not our raison d'être. It's not the reason we're here. It's not the reason we're excited to go to work in the morning. We're excited because we want to help customers, community members, and organizations at large move quickly and safely from concept to production. And we see that a lot of them struggle with this. They don't know how to do this because they are lucky enough to have been around for more than 10 years. Longer than the era of cloud computing that we know about right now, the one we're in right now. These organizations have existing applications that were written in yesteryear before the economics and before the benefits of cloud computing were so obvious and so apparent. These applications, while they were well designed for the time in which they were conceived, now present a bit of an obstacle. You see, speed is a differentiator. It is the secret sauce that helps us get to market quickly. And I don't need to look too far for supporting evidence of this, right? What is the largest taxi company in the world right now? Uber, right? What is the largest hotel brand in the world right now? What is the largest in terms of year-over-year growth car company in the world right now? And what is the largest video rental service in the world right now? No, exactly. See? It's so ironic, it's so bad that it's ironic and it's funny. It's not Blockbuster, it's Netflix. And that proves my point. These companies, when they were started, didn't have more money, didn't have more resources, didn't even necessarily have smarter people. They had the advantage of speed. They had the ability to make a mistake, to course correct and then to fix it, to constantly ask themselves to pivot or persevere. And they had this ability because they used agile processes. And they realized that they have the ability to go faster because they worked on small batches. So now we are in a good position. We understand what helps people go fast and what helps them rise the ranks of the market. Speed is very important. Even if you're making more mistakes faster, you can fix them faster, right? It's not necessarily about being better. It's about making the same mistakes as everybody else does and then fixing them faster, reducing the turnaround time. And organizations understand this, but the problem is that a typical organization has a lot of places in the value chain where time is lost when moving concepts from concept to production. So, for example, if you have a large organization, you'll typically have queuing between product management, developers, user experience people, testers, administrators, etc. That queuing is a big problem because you have to wait for people to handle the work. The other problem is that you have large existing applications, and it's very hard to move the Titanic, so to speak. It takes a lot of people to make changes, to test it, to integrate it, to stabilize it, and then finally to deploy it. So small batches of work are what we need. And we can use guidance from the good the good Eric Evans in his amazing tome, Domain-Driven Design, in which he talks about something called a bounded context. A bounded context is a part of the application that, when extracted from the larger whole, stands unto itself, internally consistent and reusable. A bounded context is a crisp definition of part of the domain model. You get rid of the ambiguity between this and some other parts of it, and you make it crisp and you extract it. If you can identify bounded contexts, you have a candidate for a small batch of work. A small batch of work on which a small group of people who don't have to spend a lot of time in meetings talking about what they're doing, they can actually just do it. A small batch of work for a small group of people that can be evolved and deployed independent of each other. A small, singly focused, independently deployable, internally consistent, reusable batch of work. This is a microservice. A microservice is a unit of organizational agility. It happens to be the best architecture for scaling out horizontally, but don't think you need to move to this architecture for that. That is not the goal. If you move to microservices because you're trying to scale, you're crazy. You're not Google, you're not Netflix. Solve the real problem first. Solve your organizational bottlenecks. And you can do that with microservices. Microservices are a hack on Conway's Law, which says that software reflects the organizational structure that it serves. It mirrors it. So if your organization has a crappy organizational structure, you're going to have crappy software. Fix that by building teams that you want to reflect the software in the software. So when you move to this architecture, you have two problems. We've looked at Spring Boot. Spring Boot solves the first problem. The first problem is, how do I quickly stand up a new service safely, consistently, and usefully? How do I do that? Because I'm going to have to do that a lot, right? If it sucks to stand up one service, one organization, one application in your organization, you're going to be in complete hell when you move to microservices. That's the first problem you have to solve. Right? Most organizations I've seen have this nightmarish wiki page, 500 easy steps to production. That wiki page is the enemy of velocity, and you need to get past that. It has to be quick to stand up a new service. Spring Boot makes it quick to stand up a new service, and do so with production readiness in mind to support security and observability and consistency and all these other things that you need for every service that don't directly contribute to the value chain. That's the first problem. The second problem you're going to have is, now that you've got these independently deployed things, that implies network partitions. That implies distribution. You have now built a distributed system, and if there's anything upon which I'm sure we can all agree, it's that building distributed systems is hard. And so for that, today, we're going to look at something called Spring Cloud. How many of you have heard of Spring Cloud? Good stuff. How many of you have used it in anger? Which means, in production, basically. Okay, so for the rest of you, this is going to be a kitchen sink. If you have a phone or a computer, I would close it and then open your eyes. And we're gonna go pretty quickly because we don't have a lot of time. So remember, this is my second favorite place on the internet right here, start.spring.io. My first favorite place on the internet is production. I love production. You should love production. You should go as often as you can. The weather is great. It's the happiest place on earth. It's better than Disneyland. I love production, and you should too. But if you're not already in production, then begin your journey here at start.spring.io. This is my second favorite place. So again, bookmark it, keep it under your pillow, keep it close to your heart. If your children are having trouble sleeping, start.spring.io. If you find yourself suffering from indigestion and seek relief, start.spring.io. And if you want for inspiration in the early morning before your cup of coffee or tea, start.spring.io. We're going to go ahead and build a very simple service, and I don't have all that much time to explain the service itself, so we're going to call this the reservation service. I'm going to use Spring's web support. I'll use H2, which is an in-memory embedded SQL database. It's in memory, so it's going to lose all of its state after each restart, very much like MongoDB. So there's that. We're going to use the config client, which is very useful for centralized configuration. We're going to use Eureka for service registration and discovery. I'm going to use JPA, the Java Persistence API, because I make poor life decisions, so JPA. I'm going to bring in Actuator for operational concerns. I'll bring in Zipkin for distributed tracing and RabbitMQ for stream processing. And that, I think, will do it for now. Oh, we want REST repository support as well. Now, I could elect to go down here and switch to the full version, whereupon I'll be given a veritable ocean of options, checkboxes that represent all different types of workloads and technologies. I could select any other option here, but we don't have enough time, not nearly enough time. We also have some discretion about which language we'd like to use. Any language on the JVM that supports annotations and objects will work just fine. So Scala, Groovy, Kotlin, and Java, of course, right? That's just fine. Here we have non-choices, and people get very confused about this. They don't know when and where to choose which, so I'm going to do my level-headed best here and now to explain. Don't use these, ever. That's as simple as that. These are non-choices. These are choices in the same way that stripping naked and running in traffic is a choice. You could, but don't. Just don't. And then here we have the choice of packaging. If by some freak fluke of physics you find yourself stuck in the very, 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 very distant past, far, far beyond modern help, then choose .war. But if you're here with me in 2016, then choose .jar. This is a big part of my overarching guiding personal philosophy of make jar, not war. And again, you have options, you have choices. You should do what works for you, which in this case corresponds to doing what I said to do. So that's convenient. We're going to go ahead and hit generate, and that'll give us a new zip file. I'm going to open up the zip file in my IDE, and it doesn't really matter which IDE, so long as you have one. NetBeans, IntelliJ, and Eclipse all work great. Spring Boot tools for NetBeans, Spring Tool Suite for Eclipse, of course, and then IntelliJ Ultimate have extra plugins, but they're not necessary. You just need Java and annotation support and Maven support or Gradle support. Now, what I'm going to do is I'm going to build a nonsensically trivial domain model. Can you all see this in the back? Is that font big enough? Should I make it a little bit less big? Because it's almost too big for me. I was given the same presentation yesterday, and I was using my more bigger profile, but it's almost two more bigger. So we're going to say 222, okay? There we go. Is that ever okay with that? Fabu. So I'm going to say, I've got a domain model of type reservation. I'm going to give it a primary key, which I'll signal by using the @ID annotation, @generated value. Okay. And I'll say private string reservation name. This is going to be a JPA field that will be mapped to a column called reservation_name in the database. And I'll signal that this is a JPA annotation by using by using the @entity annotation. Now this, my friends, is the purest, most concise, most pristine, most clear expression of my domain model. It's beautiful. Absolutely beautiful. But this is Java, so that won't even be close to enough. So we'll add this constructor, we'll add another constructor, this just for JPA and JPA alone. We'll add a toString method, we'll add some getters, and there we go. And what I want to do is I want to save records of that type to the database, and I could create a manual repository object if, again, turning to Eric Evans in the amazing book, Domain-Driven Design, it's an object that is going to handle the underlying persistence, the reading, the writing, etc. But that's not business differentiating functionality. So instead, I'll defer to declarative interface-based repositories from Spring Data. I want to make this a REST API, so I'll say @REST repository resource. I'm going to use Spring Data there. And then I want to set up some sample data. So I'll say sample CLR implements command line runner. There we are. And what I'm going to do in this interface is just override the callback method called void run. And I'll tell Spring, whenever it starts up, to call this method because it's got that interface. And I'm going to use dependency injection here. I'm going to tell Spring to provide a reference to this repository, which I'm going to satisfy through the constructor. This is the correct way to do this, by the way. Never, ever use field injection, ever. Every single time you do that, a unit test dies. Don't do that, never. Not even when you're all by yourself at home, all alone, and no one is looking, ever. Okay? So, goodbye to this. Now, I've got a simple record, and I'm going to just insert some data. So my name is Josh. It's lovely to meet you. My friend Joris, how you doing, buddy? Aryan, he's over there. Jürgen just left, of course. Stefan and Brian. That's 6. That's almost a good number. What's your name, buddy? How do you spell it? Like this? Okay. And what about you, boss? FRNK. Lovely to meet you. That's 8. That's a nice even round number. I'll sleep fine tonight. It's going to be great. And so what I'm going to do is I'm going to pass in a consumer. This is a Java 8-ism, right? This is one of those new features that only very modern languages have. Languages like C, COBOL, PHP, Ruby, Perl, Lisp, Smalltalk, C++, Objective-C, Visual Basic, Visual Basic.NET, Ruby, Go, Lua, Haskell, COBOL, right? So as a Java champion, I'm very happy to talk about something called a Lambda, which is new in Java 8 that we introduced 2 years ago. And I'm going to then visit every record. I'm going to say, for every record, let's call the print line method, and we're going to print it out. Now, what that's going to do is it's going to spin up, and it's going to write all the records to the database and then we'll see those records reflected in the output on the command line. Okay. I've got just all sorts of stuff on my class path, so let's see how this goes. I'm not even sure if I should have deleted some of it. Okay, good. There it is. It worked. Of course it worked. It was a demo. What were you expecting? It was always going to work. Instead, what I really wanted to talk about was this. This is something that's near and dear to my heart, and it's basically why I'm here. This is a big problem. What the hell? Why is this here? See, what I really wanted to talk about was this. This is the Spring Boot ASCII artwork. And this ASCII artwork took a long time to get right. We on the Spring team have several PhDs, doctors, people who worked in nuclear physics, who worked very hard to make this work for you. And so I consider this particular feature a very serious deficiency in the JetBrains product. What the hell? Why is that there? And so I did what all people do when confronted with challenge and struggle on the internet. I went on the internet and I cried. And I was greeted by a message of hope from my friend Jan Sabron, who's a software developer by passion at IntelliJ JetBrains. And he responded with this message, which I share with you here now. Don't worry, my friends, we're going to make IntelliJ great again. Anyway, so we've got now a REST API. We can go visit the REST API by going to reservations, and we can see here that I've got a collection of resources. This blue box, I'm not sure if you can see it in this tiny little screen there, but that blue box is a resource. It's an envelope object with a payload and a collection of links about the payload. It's hypermedia. It's built on Spring HotOS, hypermedia as the engine of application state, which is a design pattern. Now, if you followed any of the earlier talks about Spring Boot, then you know you can change all manner of different things, for example, by going to application.properties and changing, for example, the port. But this is going to betray some of the things that we want in a continuous delivery style or agile style environment. I want to be able to move my build from one environment to another without having to recompile it. So while I could change things in application.properties and override them, I would have to recompile each time if I did that. I can instead defer to Spring's good support for 12-factor style configuration here, right? So if I go here to my build where my code is, like this, and I do maven clean install. Oh noes, thank you. And then maven -d skip test, because YOLO. Okay. And cd target, there we are. You can see I've got a so-called fat jar that contains everything I need to run the application. And I can say java -d server.port equals 8010 -jar reservation service.jar, and that'll spin up the application on port 8010 instead of the default 8080. Where's the, oh, there it is. So there's 8010, right? I can also use environment variables. So I can say export server underscore port equals 8030, and then just do java -jar reservation service.jar, and we'll see that spin up on port 8030 instead. There we are, right? Oh, come back. Son of a gun. 9. I've lost it. I blame you, Joris. There we are. 8030. Okay? So that works, and this is certainly very powerful, but it's not enough. There's several use cases for which this isn't sufficient. Suppose I want to change the configuration while the service is running. Suppose I want to support sensitive passwords and encrypted information on the file system. How do I support that? Suppose I want to centralize all this information instead of copying and pasting a configuration from one startup script or manifest or Docker file or whatever to another. And then suppose I want to change things while the service is running live. For all of these use cases and more, while this is a good basis, it's not nearly enough, and we need to do a little bit better. So what I'm going to do is I'm going to build a Spring Cloud config server. Now the config server, oh yeah. All right. Good stuff. The config server is an API that we're going to stand up that knows how to manage a directory full of configuration, and that directory is going to be based on Git, and I'm going to clone it from my GitHub repository here. Now this is one approach. You can also use Zookeeper or Console to centralize your configuration, and again, I would refer you to my good friend Joris' talk later on. But we have a config server, so I'm going to move this directory here to just config. It's on my directory. It's on my home directory in my desktop. And I've now created this new module called the config service. I'm going to open this up, and I'm going to configure it to be a config server. It's going to manage our directory full of configuration on behalf of the microservices. So, config service at enable config server. We're going to go here to the property file, and we're going to say Spring Cloud config server git URI equals, and I'm going to say home desktop config. And I'm also going to point my application to port 8088, okay? And I'll spin that up. Now, suppose I am a microservice. What I want to do is I want to have my microservices call the config server on port 8888, and then they're going to ask for their sets of configuration. So instead of having to keep all that stuff in property files in each application, I have just one service, and it has one directory. So what if I am a microservice? I'm going to name myself the reservation service, reservation-service. What configuration would I see? I would see this, 8888 reservation-service default, okay? Default is the profile. This is the property, the service name. And I'll see two property sources. One from application.properties and another one from reservation-service.properties. There are keys and values in each of these property files. If there's a conflict, like here, server port and server port, then the more specific file overrides the default fallback file. So every microservice will see the values in application.properties. Only the microservice called reservation-service will see the values in reservation-service.properties. I also have a message here. So let's go back to our little REST API with reservations and change it to be called the reservation service and to get its configuration from the config server. So here we are. We're going to change a few things. We're going to say Spring Cloud config URI equals HTTP localhost 8888. Now it turns out that the default value for this is actually exactly what I just put in. I just want you to see how it's done. So the other thing you need to do is give it a name. You have to tell it how to identify itself, and it calls the config server. Now, these two values are understandably and necessarily used by the config server before it loads the configuration for everything else. It's used in the bootstrap phase, so you have to rename this file to bootstrap.properties so that Spring Cloud can find it. So here's bootstrap.properties. And we're going to finally go ahead and use that message that we had just created, that simple hello world message. We're going to add an endpoint here. We'll say REST controller class message REST controller. Okay, and we'll say private final string message. And I'll create a constructor, and I'll auto-wire my value here from the config server. Okay, message. And I'll say I want to create an endpoint that simply returns that value whenever asked. So I'll say MSG string read, and I'll return the collection, this dot message. Okay, there we are. So now, we want this value to be available, and it will, now that we've connected to the config server. I also want to be able to change the value live when the service is running, so I'll make the bean refreshable. Now to confirm that everything is working as expected, we should be able to go to port 8000, not 8080, but 8000. That's the new port on which we launched the service. And we should see the result post-haste. Come on, computer, time is a-wasting. There we are. So that worked. Hooray. What about the message? There's our message, or not. No, I did MSG, didn't I? There we are. There's our message. It works, but it's not great. We can do a better job. So let's revisit this directory full of configuration on the in the file system here. And remember, it's using Git. That's very important. I'm using Git to manage this, or Subversion, but it's got to be some sort of thing that supports auditing and journaling. So I'll say hello Amsterdam exclamation marks for Reddit. Okay, git commit -a-m YOLO. Now, if I go to the config server, it sees the value immediately, but this has no idea. And I can change it a few different ways. I can use the Spring Cloud event bus, or I can trigger an Actuator Endpoint, which is an endpoint that is set up by Spring Boot for you to operate or get observability about the application. So I'm going to go ahead and hit empty minus, I'm going to send an empty post, and then refresh, and I can see the value immediately. This supports things like feature flags. This helps me decouple the release of software from the launch of that software, from the deployment of that software. This helps me support branch by abstraction and continuous delivery pipelines. There's a lot of power here. The config server, because it's between my configuration directory and my microservices, can also do symmetric encryption and decryption of values in the property files. So there's a lot of power, but we have to move on. The next thing we're going to look at is service registration and discovery. The thing that we care about now is for the ability of services to talk to each other without knowing about each host and port. And there's a lot of good reasons why you'd want to do this, and at first blush, at first look, this may seem like a use case for DNS, but it's actually a poor fit inside of a cloud-based environment. First of all, DNS adds latency. You have to resolve the DNS entry and then hop back in. If you're in a cloud environment, it usually involves a hop outside of the router and then back in, which is even worse. And then third of all, DNS is by definition routable. Sometimes I don't want my services to be routable. I want to be able to talk to them, but not expose them via some sort of DNS entry. I can do the multi-home thing where I have private DNS versus public, but that gets very confusing. The other problem is that I want to be able to handle load balancing, custom load balancing. Your average F5 router, for example, will have a checkbox that says do round-robin load balancing. But what about more specific business case, semantics specific use cases? Like if I have a need to do sharding, or I want to route a client to a specific node, or if I have multi-tenancy, or if I want to do an OAuth client, I want to lock it to a specific node where something stateful is happening. Some load balancers have a dumb notion of stateful or session affinity or sticky sessions, but that doesn't apply to non-standard things like an OAuth token, for example. So how do you support all of these use cases? We don't want to use DNS in your average big dumb load balancer. Instead, let's use something called a service registry. A service registry is like a phone book for the cloud. It's a logical mapping from a service ID to host and ports. And there are many different implementations. And again, you can talk to my friend Joris a little bit later for his talk, but there are many different implementations out there. Apache Zookeeper, HashiCorp Console, etcd, Cloud Foundry. We have abstractions. We have an abstraction that has implementations for all of them. But I'm going to use Eureka because it was developed by Netflix. It's very, 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 very proven. It's been used at scale for years. And it's dead simple to set up. And I'm very lazy. Very lazy. I mean, you would not believe. So I'm going to say config client Eureka service. I'm going to build my own Eureka registry here. And we're going to do the same thing as before. We're going to tell Eureka where to find the config. So Spring Cloud config URI equals HTTP localhost 8888. I'm going to give it a name. So we're going to say Spring application name equals Eureka service. And we're going to rename this property file to be bootstrap.properties as before. And then we're going to open up Eureka service application. I'm going to say abracadabra, you're a Eureka. And that'll spin up if everything goes to plan on port 8761. Now, we don't know. This could all go south in a minute. Oh, son of a gun. Why? Oh, good. Okay, so first thing you need to notice is that we have good quality animated GIFs. Very, very well done. Now, the other thing you need to notice is that we don't have any applications registered yet. So let's go back to our reservation service and teach it how to raise its hand, how to say, listen, if anybody needs me, I'm right here. This is my host. This is my port. On the client in the build, we have Spring Cloud Starter Eureka somewhere. Don't we? There it is. That's the Discovery Client Abstraction implementation for Spring Cloud. So all I need to do is to enable that abstraction by saying @enable or @enable Discovery Client, and then I'll restart. And that's going to raise its hand and call home to the registry and say, listen, if anybody needs me, find me here. If you have 10 instances, they're all going to call the registry. Now what we're going to do is we're going to build a client to use the service, a edge service, okay, an edge client. So we're going to call this the reservation client. We're going to use the config server. We use Eureka for service registration and discovery. We use Zipkin for distributed tracing. We use RabbitMQ for stream processing. We're going to use Zool for micro proxies. We're going to use Hystrix for circuit breakers. We're going to use REST repository support, web support, Actuator support. And then we're going to go ahead and hit generate, okay? Now, this is the same as before. I'm going to open it up. I'm going to configure it and point it to my application, my config server, rather. So there's this. So Spring Cloud config URI equals HTTP localhost 8888 spring.application name equals reservation-client. And we're going to rename this property file to be bootstrap.properties. We'll open up the code and @enable a discovery client abstraction implementation. Now, think about what we're going to do here. An edge service is a logical component. It lives at the edge of the architecture, responding to requests from outside, from your HTML5 devices, from your iPhones, your Androids, your PlayStations, your Rokus, your Xboxes, your Teslas. In the Internet of Things, it could be your microwave, right? Anything these days has an IP. So each of these clients have specific payload, protocol, and security concerns. And if you have to change every single microservice to accommodate all of these new clients, you're going to be redeploying stuff all year long. It's insane. So don't bother. Centralize those concerns at the edge. The edge service is going to be exposed via DNS. But then when the edge service looks for other services in the architecture, in the cluster, it's going to use service registration and discovery. Your iPhone isn't going to use Eureka, for example. Right? It'll use a DNS endpoint, but then from there, it'll be using service registration and discovery. So what we want to do, for example, is to build an edge service that handles client-specific concerns. You may have an HTML5 edge service, an iPhone edge service, an Android edge service, etc. Think about HTML5. HTML5 is ridiculously powerful today. An HTML5 browser can do all sorts of interesting things. I think this guy's actually from here, maybe. Have you seen JS Linux? This is insane. So this is, yeah. That is actually a browser completely in memory booting Linux. So don't tell me you need to build a native desktop application for Windows anymore. It's just ridiculous. We just booted Linux entirely in JavaScript. The point is, you can do a lot of stuff in the browser today that you wouldn't think possible. So you don't really need to hold its hand and babysit it for computational stuff. But you do have to understand that it lives in a sandbox. It cannot make requests outside of that same host and port. You can add a policy to every microservice, but then you'd be changing every microservice to accommodate the new client. We want to avoid that. One way to avoid that is to proxy all of my services that are registered in Eureka through a single host and port. And we can do this using the microproxy. A microproxy is a design pattern that blindly proxies things back and forth. And we're going to use something called Zool. Now, Zool is a microproxy from Netflix. I'm not sure if you keep abreast of your Greek and Ghostbusters mythology, but this is Zool. Now, Zool is the gatekeeper to the underworld, to Hades, to hell, or at least that's what I thought. But then my friend said, you know, Josh, that's not fair. We don't know that. In the movie, they don't say that. He might come from a very nice place. He might come from Hawaii. We can't judge. And so, you know what? He's right. I'm sorry. That's what I thought it was. You know, I don't know. Anyway, he's the proxy to wherever, to Hawaii. Okay? And now, Spring Cloud and Zool have already set up an edge service for me at 99.99 / reservation hyphen service / reservation. So this is the edge service port. This is the service ID in Eureka, and that's the actual path. Remember, I actually have a real service here on port 8000. So real service, edge service, real service, edge service, real service, edge service, real service. It's a proxy, my friends. It's proxying it. You can see that the proxy sends a header to the downstream service. The downstream service uses that header to rewrite these URLs so that from the perspective of the client, it doesn't know that that JSON didn't come from that node, right? This is very, very powerful. So maybe I'm done, you know. All of my services that are in Eureka, I can access them by using them as the service ID as the context path. Then I'm done, maybe. For my HTML5 developers, assuming all of my services are homogeneous REST and JSON, maybe I go home. I should probably add HTTPS, or actually certainly add HTTPS. I should probably add HTTP basic or OAuth kind of authentication, but maybe I'm done otherwise, right? Maybe I've done everything I need to empower them to be done. Sometimes, however, it's useful to have a subset of the data or a view of the data or a transformed endpoint that has a composition of other services. This is a different kind of edge service called an API gateway. A microproxy is a dumb proxy back and forth. It's an edge service. An API gateway does some sort of translation or transformation of the request or the reply or both. They're both edge services. So we're going to build a very simple API gateway that simply takes the downstream reservation service and gets only the names. We're going to strip away the strata of all the surrounding JSON. We want just the names. Now, in order to understand how this is going to work, we need to first think about how this worked. How come it's able to route that request? How does it know? It's making the request by going to Eureka, and it's using that service ID, and then Eureka is saying, I've got 10 instances of that service. How does it pick which instance? It's making this decision on the client using something called Netflix Ribbon. Ribbon is a client-side load balancer, right? So we've got that already in play. Ribbon gives you the ability to, by plugging in an object, do different kinds of load balancing. You can do round robin, which is the default, or sticky, or data center aware load balancing, or sharding aware load balancing, or whatever you want, right? So we're going to build a very simple edge service here. We're going to say class reservation API gateway REST controller, and that's very succinct, I know. And I'm going to root this endpoint at reservations. I'm going to make it a REST controller, and I'm going to take advantage and create an endpoint here that just returns the string names. Okay, just the names. So whenever somebody goes to localhost 99.99 / reservations / names, this endpoint is going to be called. And I'm going to use a REST template from Spring Framework to make this call as quickly and concisely as possible. But the problem is my REST template doesn't know about Eureka yet. I need to make it aware. So I'm going to configure a Eureka aware, a load balanced and ribbon aware REST template here. Okay, return new REST template. And I'll then make sure that I qualify that injected version here with a qualifier annotation. And I'm going to say, call the REST template exchange method, call the reservation -service. It doesn't matter which one. Remember, this is not DNS. That's going to be intercepted by the load balancer. It's going to find an instance, and it's going to pick it and then substitute it for the string. I'm going to say, make an HTTP GET call, no body. And then I'm going to say, I want the data to be returned as a collection of Spring HotOS resource objects whose payload is of type reservation, right? So I'm using the type token hack, design pattern here to do this work. The type token hack gets around the fact that Java doesn't have good generics, a good generic type system. So here's my getter. I'm making the request. And now, when the REST template returns, the REST template will return a envelope object called a response entity. And the response entity has a payload of type resources of reservation. So I'm going to say response entity.getBody.getContent.stream.map. I'm going to map from reservation to reservation name, and I'm going to collect it all in a list. So there, my friends, is a very, very simple edge service. It's 2 lines, 2 admittedly terrifyingly crazy lines, but still just 2 lines, right? And those lines are going to do what we expect. They're going to take the data and turn them in to a collection of resources whose payload is of type reservation, and then dereference the reservation name and collect all that in a string. So we can see that here, localhost 9999/reservations/names. And that's working just fine. But what happens in the case of a failure? I need to degrade gracefully. High-performing organizations understand that failure is a fact of life. It's an inevitability. Netflix have a suite of software components called the Simian Army. The Simian Army are basically little software terrorists. They run around in production during office hours, kill -9ing processes, blocking ports, RMRFing database and disk partitions. They even have something called Chaos Kong that, even as I talk to you about it right now, gives me goosebumps. It kills a whole data center availability zone on purpose. Ugh. They do this because they'd rather find out during office hours when engineers are on call that it's going to work than to wait until 4 in the morning when it's an actual emergency and nobody's awake. So we need to understand that same fact as well. In a sufficiently cloud-native system, high availability of a single node is an illusion. It'll never happen. Instead, you need to optimize for time to remediation. A cloud-native architecture is one that is built to survive and thrive at scale and horizontal scale. A cloud-native architecture is also one that is built to understand and do the right thing in case of a failure. We need to optimize for time to remediation. How quickly, from the perspective of the client, can we get up a new service or load balance to another endpoint or do something so that it looks like it's still working? If you build your application with time to remediation in mind instead of high availability of a single node, then from the perspective of the client, you'll have the same result. But this has profound implications on how you build your systems and how you architect it. So in this case, we already have 80% of this working just fine. If we call that downstream service and there's 1 or more instances of that service in the registry, this will work. It's not going to work if there are 0. Right? If there are 0 instances, this is going to blow chunks, and our poor iPhone users are going to get a big fat Java stack trace in their phone. That's no way to run a railroad, my friends. We need to do better. So we're going to introduce graceful degradation. High-performing websites do this kind of thing all the time. They'll say, oh, well, you wanted the search engine results, but those aren't available right now. So here are some machine-learned recommendations from across the web. We're going to use something called the Hystrix circuit breaker. And the circuit breaker is going to be a stateful component that we're going to add to our potentially shaky service-to-service call. So if there's a failure, if there's an exception in this method, we're going to have it call another method of the same signature and form called fallback, and we're just going to return an empty array list, okay? So there's that. Now this circuit breaker is stateful. It's going to see that there's enough exceptions, and it's going to stop the traffic and go directly to the fallback after a while. This gives our downstream service time to come back to life. If you're using something like a cloud platform like Cloud Foundry will move heaven and earth all day and all night to restart services if you need it to. If you say there's got to be 10 instances or 100 instances, it will make sure that that is true all the time. But it's up to us as architects and developers to do the right thing in the software in the face of topology and architecture changes like this. So this is what we're doing. We're accounting for the possibility of failure, which is a real thing. So, okay, good. I'm making requests. Happy path. Things are working. Great. Now let's go back to our reservation-service and then kill the poor, poor reservation service. There we are. That's sucking, isn't it? Look at that. It's hesitating. Eventually it's going to time out, but I can force it to time out and force it to go directly to the fallback by hitting Command-R. There we go. So now, each time I do that, it just goes straight to the fallback. It doesn't even try to call the downstream service. We're giving our downstream service time to recover, time to breathe. We all know that if a service isn't responding, you should hit refresh on the browser, right? Does that work? Well, it doesn't work for distributed systems either. This gates that effect. This gets rid of that effect. Okay, now, my friends, we've only got, how long? 7 minutes? 8 minutes? So we're going to be a little late. probably 8 minutes. We need to now care about observability, right? So a cloud-native architecture is one that is observable. It's one that scales out correctly, and it's one that does the right thing in the case of failure. It optimizes for time to remediation. That's the 3 tenets of a cloud-native system. We've looked ever so briefly at how to build a system that does the right thing. It centralizes configuration, it uses service registration and discovery. We've introduced graceful degradation in case of the read. If I had a few more minutes, I might show you how to do a bit of graceful degradation in the case of a write when you post data, right? If you post data, you want to deliver the message eventually. And for that, you can use something called Spring Cloud Stream. This gives you eventual consistency. There's a lot of ways to get 2 different services to agree on the state of something. One is to use eventual consistency, which is messaging, basically. That's what we're implying. Another one is to use the saga pattern, which describes a set of interleavable, that is, you can switch the order, transactions that each have semantic compensatory transactions. Another way is to use a more sophisticated version of messaging called CQRS and event sourcing, right? But we will skip all that for now because that could be another 5 hours. So instead, let's talk about observability. There's, in my system, on each of my nodes, I have the actuator endpoints. The actuator endpoints give me information about what the application is doing. So if I go to my edge service here, 99.99.9/metrics, I can see information about this host and this node, right? Memory, uptime, heap, non-heap, code cache out, etc. This is all pretty standard stuff. Now, I've also got env, which shows me my environment, beans, which shows me the objects in the graph, etc. But these are host and node specific information. I want to see the emergent behavior of the system. Remember, the map is not the terrain. My architecture diagram is not the architecture. It's not the system. There's emergent behavior that your system has that your architecture diagram will never understand or never be able to encapsulate. So we need to capture that. We need to have the observability. We're going to use a few different things. We want to look at the flow of traffic in that circuit. That circuit represents a connective tissue from a consumer and a service, a producer and a consumer, a client and a service. That service may be down, right? If it's a third-party service especially, we have no way to instrument that third-party service. So we can use a circuit breaker to add a connective tissue that looks at the transit of data through that endpoint. So one thing you should notice is that I went to my, a few seconds ago, I restarted the reservation service and nothing else, and now the circuit breaker is working. It's reintroduced traffic. So it saw that traffic is working and it came back. It healed itself. But it may fail again, so I want to be able to see what's happening. I can do this with the Hystrix dashboard. I'll say Hystrix dashboard, config client, Eureka, service registration discovery. I'll hit generate. I'll open this up, and I'm going to open this up in my IDE, and I'll do the same normal kind of thing as I've done before. Application.properties, Spring Cloud config URI, HTTP, localhost, 8888, spring.application name, Hystrix dashboard, properties.bootstrap.properties, Hystrix dashboard application, and I'm going to say, @enable discovery client, and finally, I'm going to say @enable Hystrix dashboard. Now, this is going to spin up on port 8010, and what it's going to expect is a server sent event stream, a heartbeat stream that each of the nodes that has a circuit breaker will emit automatically. This server sent event stream can be multiplexed. You can take all of the streams from all of the service instances and put them into one big stream using Spring Cloud Turbine. But that's a demo for another day, my friend. So for now, let's look at the simple case of this one node and this one heartbeat stream. So localhost 99.99 hystrix.stream. Now, this stream is never ending. It's infinite. It's always being updated. There's always new data. It is endless, like the bugs in my code. It's going to keep going forever. So whatever you do, do not curl this endpoint, okay? I'm going to take that URL. I'm going to go to 8010/hystrix.html. I'm going to put this in the dashboard that we just created, paste, monitor, open this up, localhost, reservation names. Now, I'm going to drive traffic on the left, and we'll see that reflected in the moving average that trends ever upward on the right. You can see that traffic is going through the circuit breaker just fine. There's 30, 36, 42, whatever requests. Everything is green, though. The circuit is closed. Life is great, okay? If I were to kill the service, then we'd eventually see the circuit would be open, and it would go to the fallback method directly. So that's one way to get a visibility into the emergent behavior of the application. The other way to get that visibility is to use distributed tracing. And distributed tracing is actually, in theory, very, very simple, but in practice, very, very painful. What we want to do, my friends, is to instrument every ingress and egress point. That is to say, every place where a message can arrive or leave a Spring Cloud application. Spring MVC, the REST template, Spring Cloud Stream, the Feign declarative REST-based clients, the microproxy based on Zool, all these places where messages arrive or exit. We want to make sure that we intercept them or filter them and see if there's a unique ID that we can use to correlate the flow of a single message through the entire system. In distributed tracing parlance, we talk about a trace and a span. A trace represents the whole journey from A to Z of a request, from A to Z. A span is each leg in the journey, A to B, B to C, C to D, D to E, etc. And we have a framework called Spring Cloud Sleuth. So I'm going to say Zipkin server, Zipkin UI, Eureka service registration discovery, config client. We're going to hit generate. Now, Spring Cloud Sleuth is already working on our applications. I've got this on the class path, and you can see it's already doing something useful. It's logging information here. This is the service ID, the trace ID, and the span ID. So if you have a log analysis tool like Elasticsearch or Papertrail or Splunk, you can already see some of the information as it flows through the system. But I believe that an image, a graphic, a picture is worth 1,000 traces. So we're going to use Twitter's Zipkin service. We're going to build a Zipkin service here. We'll say @enable Zipkin server. Come on, computer. What are we having trouble with? Did I do something wrong? Come on, computer. Okay. No reason to cry yet. There might be, though. There might be. Come on, computer. So, Zipkin service application. Santa Maria. I don't even understand what happened. That's the thing. Can we have 2 minutes? 3? 3 minutes. Can I have 3 minutes? We're going to do the nuclear option, and then I'm going to stick the dismount. I'm going to restart all the IntelliJs. In IntelliJ, we're going to have a big talk after this. Okay. Terminal, pkill. It's a good thing we don't build distributed systems on IntelliJ. Okay. So, config server. Open. Eureka service. Open. Reservation service. Open. Sorry, what, huh? Okay, that sounds like the nuclear option. Yeah. Bad IntelliJ, bad. Okay, hold on. Yeah, it'll take forever. He's got a point, my friend. It's scanning files to index. It looks like it's already doing something to that effect already. Reservation service. Santa Maria. Config service. I just want to know it's going to be all right. I just want to feel secure in my life choices. Should I have used IntelliJ? Should I have used Eclipse? Emacs? Every talk I go to, there's always that one person who uses Emacs. I always ask who uses this, that, and the rest, and there's always the same guy. I use Emacs, he says, and then he leaves the room. And I think he's just going to the next country or continent where I am. He's a troll. So, config service. What about you? Why are you so upset? Zipkin UI. Well, Santa Maria. So the reservation service, wait, config service is running, Eureka, reservation service, okay. Oh, come on, Zipkin. Okay, so I fixed the build problem. I'm going to say @enable discovery client @enable Zipkin server. Okay, so reservation service is up and running. Eureka's up and running. Reservation client, not so much. Let's see that everything is working happily. Localhost 9999/reservation names. And then my Zipkin server, I need to point that to the right things. So we say application.properties, spring.cloud.config.uri equals localhost 8888 spring.application name, Zipkin-service. Rename this to be bootstrap.properties. Strap.properties. Okay, and go. Come on. That's the service, config service, Eureka service. Client is now springing up to load. Come on. Yeah, here we go. Reservation names, read. Come on. Okay, failure. Good, it's working. Now, Zipkin. So we've already got the tracing on the command line. That's useful, but I want to visualize it. So I'm going to open up Zipkin, which is what I just set up. Zipkin is a distributed server, a distributed tracing server from Twitter. It was open sourced in 2010, and we have people on the Spring Cloud team from both Netflix and from Twitter who contribute often. So they helped us make this stuff really great. So here we have visibility into 2 services that are already registered. I'm going to go to reservation service, for example. I'll hit find traces, and it'll show me that I made a request less than a minute ago. I'm going to click on that request here, and I'll see a waterfall graph that said I made 88 milliseconds. Good gravy. That's not the average one. Let's try a different one that makes me feel better. Something's wrong. Anyway, 67 milliseconds. The request entered here at HTTP reservation names. Then it flowed out of the reservation client to the HTTP reservations endpoint, and then finally that arrived at the reservation service here. I can click on this information to get details about the flow of the message in the system. I can click on this, for example, to see tags and show the actual log of the message. Now, this is information that you can use to correlate transactions with requests. Make no mistake, however, this is not for customer service. You're not supposed to use this to find out what Jane did on the website 2 years ago. You're going to keep, at most, a couple of days' worth of logs. This is about online telemetry right now. How much money did we make last quarter? I don't know, but I can tell you what the average latency on the website is right now. This is for that. Okay, it's observability of the online system right now. You will trace at most maybe 10%. That's the default. We trace for you automatically. I have it at 100% because I do a demo. You're going to get, by default, 10%. Twitter, for example, keeps 1 out of every 6 million requests. 1 out of 6 million. They don't need it all. So, my friends, I'm sorry that we didn't get to cover much this time. Maybe next time we could actually get into the details if I just had a little more time and if I just would stop sucking with the code. Now, thank you very much for your time. I want you to I hope you appreciate that while I am wearing a Spring t-shirt and Spring underwear, and I'm a big fan, you don't have to take my word for it. There are small organizations out there that are doing amazing things with this. So several world governments, Alibaba in China made $14 billion in a single day last year. They're using Spring Cloud Loud and Proud. Netflix is using Spring Cloud Loud and Proud. Baidu is using Spring Cloud Loud and Proud, right? These are organizations that have the money, the people, the motivation, and the resources to solve this problem themselves, and they still choose Spring Cloud because it represents the most powerful way to build these kinds of systems, the most cohesive way to build these kinds of systems. Thank you very much for your time. I'm sorry I ran over. Thank you, Vel. I appreciate it. Cheers.